Hello everyone. Previously we discussed about this one bubble sort. So basically today we'll be discussing about the count sort, and we will write the code and try to understand how the count sort works. Also, finally let's discuss the time complexity and the space complexity, right? So counting sort is a non-comparative sorting algorithm. So previously we discussed about the bubble sort. It was a comparative algorithm as we have discussed. So here this is non-comparative sorting algorithm that basically works well with the range of input elements that is not significantly greater than the number of elements. So here this line is very important. Again, I'll tell you, it works well when the range of input elements is not significantly greater than the number of elements. So it operates by counting the frequency of each element in the input array and then using this frequency information to place each element in its current position in the output array. So let's see this step by step. How can we write this one? So first what we will do, we will determine the range. So first we will find the minimum and maximum values. So first we will find min and max value in the array, right? So this will be the first step. Why we are doing this? We have to establish the range of the elements, right? So that is the reason we'll be finding the min and maximum value in the array. So next, after determining the range, we have to count the frequencies. Nothing but we will use the count array to track the frequency of each unique value in the input array. So how many times the element is repeated, that is what the frequency is, right? So we will count the array to track the frequency of each unique value. So basically we are counting frequency here. So I'll just write EQ. So here we'll be counting the frequency. After finding the minimum and maximum value in the array, we will be counting the frequency in the of the each value in the input array. So finally what we will do, we will convert the count array so that it holds the cumulative counts. Nothing but we should have the count of that particular element, right? How many times it is present in the array. So this will help basically in determining the final position of each element. So here we are calculating positions in the third step. So third step, what we will be doing, we will be calculating positions in the third step. So after the third step, let's come to the fourth step. Nothing but here we have to build the output, right? After that, we have to iterate through the input array in reverse. So here, let me write reverse iteration. Alright, this is nothing but the reverse iteration. We will iterate through the array in reverse, placing each element in the correct position in the new output array. So we'll initialize the new array and we'll be storing the values in the new array, right? So we'll be iterating in the reverse order. Basically here we'll be doing the reverse iteration and we'll be placing the array of elements here in the correct order. So this will be the elements, right? So the final step will be copy. We will just copy back. Nothing but we will copy the sorted values from the output array back into the original array. So this will be just copy back, right? So we are just copying the sorted values from the input array back into the original array. So I'll just delete this. Let's write the code to understand this one, right? So initially, just give me a second here. So initially what I'll do, I'll just make use of the this one. Let's start writing first here. Let me give function counting sort of array. I'll just take the parameter array. Here, the first step is we will find the maximum value. As we had discussed, first we will find the maximum and minimum value in the array. So I'll directly consider math.max here. And let me make use of the spread operator here. This will be so that we'll get the maximum value. Then we have to find the minimum value. Just give min here. Same thing. I'll just go with math.max. Again, I'll make use of the spread operator over here. This is clear. Next, we have to calculate the range of elements as we had discussed. So I'll just write here const range equals max minus min, so plus 1 as it starts from 0. So here max minus min, this is plus 1 because the range starts from 0, right? So next step will be we'll be initializing the count array based on the range. We had discussed that we'll be initializing the count array, right? So based on the array, based on the range. Why we are doing this one? We have to keep track of the frequency of each number, how many times the number is repeated, or this array will basically track the frequency of each number. So I'll just come here. Let me give const count equals new array of, we have a range and we will initially fill this one with 0. So we are just initializing the count array based on the range. Next step is we will initialize the output array to store the sorted result. So we have to store the sorted result somewhere, right? For this purpose, we'll be initializing the output array. Nothing but I'll just take the variable name output here. This one will be new array of array dot length here, and let's fill this one with 0. Nothing but here we'll get the final sorted array within this array, right? Next step is we will store the count of each element in the input array. So while discussing the approach, I said that we will be storing the count of each element, nothing but the frequency of the element in the input array, right? For that, let's iterate this one. Let's carry on with the iteration. Here it will be I equals 0, I less than length of the array, and I plus plus. So let's adjust the index by subtracting minimum to fit in the range. So I can write in this way, basically. Here within the array, iterated value of the array here, this has to be, I'll just give min here. We have to increment this one. So this is fine. So we are just adjusting the index by subtracting min to fit within the range. So last step what we did, we should be able to store the count of each element in the input array. That's what we did in the last step. So in this step, we will modify the count array to hold the actual position of elements. Let's see how can we modify the count array to hold the actual position of the elements. Again, here we will start with 1 basically. I equals 1. This has to be length of the count, and let's increment the I. This has to be count equals iterated value of the count, it has to be, right? So yeah, this has to be previous element, nothing but count of I minus 1. So I hope this is clear till here. So after this step, let's build the output array by placing the elements in the correct position. So we have to place the elements in the correct position, right? So I said we'll be doing the reverse iteration. If you remember, that was the step number 4 or 5th I said while discussing the approach. After doing this, we'll be placing the elements in the correct position by making use of the reverse iteration. So we'll be going with the reverse iteration. Here it will be array dot length. This will be minus 1, and I greater than or equal to 0, I minus minus. So this is fine. Let's place the element using the let's place the element using the count arrays index. So I can write in this way here, this one output of count within the array, iterated value of the array of this one I. This has to be minus min minus 1. This will be equal to iterated value of the array. So finally, we have to decrease the count after placing the element. So we have to decrease one this thing, right? One index, right? So how can we write that? So count of array of I minus min. So let's decrement this one. So we are decreasing the count after placing the element. So I hope this is clear. The last step is we have to, as we had discussed, we will copy the sorted elements back into the original array. So this one will be for I equals 0, I less than length of the array, and let's increment the I. We will update the original array with the sorted values. Finally, this will be array of I equals, finally we are going with the iterated value of the output. So here, this one we have considered here, right? So this one. So this is it for the code. Then let's try this one with the example usage. So I'll just give here const array. I'll just take some random numbers here. Let's give this a frequency 2 twice, 8, 3 also twice, this one. So this is unsorted array, right? So I'll just make use of the just give me a second here. Yeah, console log of, so this is the original array, right? See, this one will be original array. So sorry, this has to be this one, array, right? Small array. So why am I doing this? Yeah, basically let's call the function here counting sort. I have taken counting sort of the array. So we need to display this one, right? Sorted array. So I'll just take console log of the sorted array. I'll just mention this one within the string. Sorted array and array. So we have to display the sorted array. So here, this is fine. So let's check whether this works or not. Let me run this one. So here, reference W is not defined. This has to be 2 actually. Any number. So now you can see we had given 4, 2, 2, 8, 3, 3, 1. Now 1, 2, 2, 3, 3, 4, 8. So these counting arrays will be helpful when we have the frequency of the element. When we have more than this one, the frequency of the element, each element is. So basically, when we have the duplicate of each element, right? So if we are having the duplicate elements in the array, then this counting array will be very helpful. So here you can see we are getting this one in the ascending order. You can try this one with the descending order. So I have showed you the ascending order, right? 1, 2, 2, 3, 3, 4, 8. This is working absolutely correct. So let's discuss the time complexity and the space complexity. Here, the time complexity will be big O of n plus k. Why? Because we are iterating through the input array, which will be big O of n, and the count array, which will be big O of k. So input array and the count array. So the overall time complexity would be big O of n plus k. So what will be the space complexity? The space complexity would be big O of n plus k as well. Why? Because we are making use of the additional space that is used by the count and the output arrays. So both will be of the size n and k, right? Where k is the range of the input values. So the overall space complexity would be big O of n plus k as well. So I'll just come here. This will be big O of n plus k as well. So this is it. This also works properly. As you can see here, the output, the code also works properly. So this is it. Thanks for watching, guys. And